practice problem number 2. We're told that two lines are graphed on the same coordinate plane. The lines only intersect at the point 3 for x and 6 for y. Which of these systems of linear equations could represent the two lines? Select all that apply. The key here is to again understand that where the lines intersect is our common solution. So this problem is really asking which of these linear systems, at least two of them, which of these linear systems has a common solution of 3 for x and 6 for y. So I've written down the first two linear systems here. Later on, we're going to write down the other three. The key here, I would use substitution. Substitution, or as Mr. Neville would have said last year, we'll get up there, substitution, replacing variables with the number they are potentially equal to. This is the plug part of plug and chug if you were thinking back to your work with Mr. Neville last year. So I'm going to go ahead, full screen this whiteboard with the first two equations. And we're going to go ahead and substitute in this ordered pair, the proposed common solution 3 for x and 6 for y, into both of these equations. In the first equation, if I plug in a 3 for x, the equation is going to be true. It'll say 3 equals 3. There's no value for y to plug in, so this ordered pair could be a common solution to the first equation. And here I need to plug in a 6 for y. So I see that the first linear system, this very simple linear system, if I use substitution, A is one of my correct answers. It is two simple equations where if I plug in a 3 for x and a 6 for y, both equations are true statements. The next one we'll take a look at, x equals 6 plus y. So I plug in a 3 for x over here. I need to plug in a 6 for y. And I see this equation is going to simplify to say something that is a false statement. 3 does not equal 12. This ordered pair is not a solution to the first equation. I don't even need to check if it works for the second equation. This can't be the common solution because it's not going to work for this equation. So I know B is wrong. Very quickly here, we're going to have to grab two of the other linear systems. Bear with me. So we get y equals 3x minus 3. And y equals x minus 1 for the first, or answer choice C. And then we see again for another option, x equals 3 plus y, if we're looking at answer choice D right now, and y equals 6 plus x. So we're going to again plug in that 3 for x, that's 6 for y into both of these equations. So we're going to test for both of these linear systems. Does x work for 3 and a 6 for y? Will that work in both of the equations? So if I plug in a 3 for x in the first one, that becomes 3 times 3 minus 3, and the y is going to become 6. So I substitute the 6 in for y, the 3 in for x. 3 times 3 gives us 9. And we see that 3 and 6 works in the first equation, but it needs to work in both of these equations to be the common solution. Here I'll plug in a 6 for y, a 3 for x. This ordered pair does not work in the second equation, so C does not have a common solution of 3 and 6. I'm going to plug this in for answer choice D. And then you'll do the same thing for answer choice E, and remember you're going to need to find at least one more common solution. So it's your job right now to be finding what is the other common solution here. At least one of D and E is going to work. You're on your own to figure out which one it is.